We have a complaint of a walk-in freezer that's not working. Now, granted, this is discharge air. It's 30 degrees right now, so that's not good. We've got a thermostat right here. Looks like it has a little moisture in it. But if we can get in there, it's set for -10, and it's not calling. We don't have any ice buildup on the back of the coil, so that's a good sign. Realistically, it looks like maybe some moisture intrusion too. But we're gonna go ahead and need to get onto the roof because looks like everything down here is doing what it's supposed to be doing. I will make a note that they've had someone come in and put these stupid energy efficient motors in here, and they put these chintzy plastic blades and motors, and the things are just vibrating, but that's their problem. These things are junk. And they don't want me to change those motors. Like, they want to use their own. It's just silly. But anyways, we'll leave that alone, and we'll get up onto the roof. My condensing unit is right here. It's not a good sign when the compressor's not running, but both the condenser fan motors are. That's not good. The compressor is really warm to touch. And I've got my field piece meter right here, the SC480. And this is a 3-phase 208 volt system. So we've got 209 from one phase to another, 210 from one phase to another, and $212 from one. So we have 3-phase power going to this compressor, and it's not running. So what we need to do is shut this guy down. All right, so it's shut down. One thing I will say is this condenser fan motor is moving. This one doesn't seem like it's running. It seems like it was just moving like ever so slightly, really slow. And it's making a squeaking like bearing sound. All right, next thing we need to do is we need to pull the electrical wires off the compressor, and we need to check to see if we're off on internal overload. If that's the case, then we can attempt to cool the compressor down. So let's get in there. Got the electrical wires disconnected. Disconnect switch is off. We're testing continuity, or putting our meter on ohms, okay? And we're checking to see what the resistance value of the windings is. So from one leg to one leg, we have nothing. Okay, and then the next one, nothing. And then this one, nothing. All right, this compressor potentially is off on internal overload. Okay, so we are going, that's a whole nother problem. What the heck was that about? Ugh, stuff. All right, anyways, so I'm gonna go get a water hose and the cool presser tool, and we're gonna try to cool this compressor off to see if we can get the internal overload to reset on this guy. What I did was I put a water hose on the compressor. I'm using the cool presser tool, and I'm able to slowly run water across the compressor. I went ahead and clamped on with my field piece SC480 and put my meter on tone, right? So within the continuity feature, if you hit the select button, you can put it on tone, and it'll tell you when you have a direct connection or a direct short, okay? So our windings now have a direct connection because the overload reset. Now I highly suggest that if you do this, you let it run for about 5 minutes after it resets, okay? Because even though it reset the overload, the internals of that compressor are still really hot, so just let it keep cooling for about 5 to 10 more minutes. And when you do turn it on, you don't want to turn it on and off, okay? If possible. You want to just go ahead and let it run if possible. Now, I suspect that we're going to run really high head pressure, so I don't know how long we're going to be able to make it run. But I do want to see what happens when we turn it on to see if the compressor even works before we start going through the process of cleaning the condenser, changing condenser fan motors and all that stuff, okay? Now in this situation, I also have my field piece gauges, the S-Man 480V, installed on the system. We do have refrigerant pressures equalized out, yeah, you guys can hear the tone. And also I installed the electrical cover. It's not going to be perfect, but I tried to install it in a way that hopefully it's not full of water in there, but I can always dry it off, okay? So I think that we've got it cooled enough at this point that we're going to go ahead and turn off the hose, and then we're going to turn this guy on and see what happens. Now this is a piston driven reciprocating compressor, and on this style of compressor it doesn't matter which piston goes up first, okay? Typically there's going to be 2 pistons in this guy. It doesn't matter if one goes first or the other one goes first. So the rotation, the phase rotation, is irrelevant on this style of compressor, okay? Now if you had a scroll compressor like that one doesn't have pistons, it does matter. But this one right here, it doesn't. I dried off everything in here. We've got good electrical connections. We're going to put the cover back on, and we're going to go ahead and put our amp clamp on the compressor, so that way we can test the current and know what's going on there. So let's go ahead and click this guy right here and see what is happening with that compressor. And I'll go ahead and there we go, something like that. So you put it on the voltage setting on the SC480, then you hit the select button, boom, now you can test current. So we've got that taken care of. Gauges are installed, everything else is good. We're going to go ahead and turn this guy on. Compressor started. Ooh, sounds rough. Sounds very rough. It doesn't sound good at all. We're going to give it a minute, see if it calms down. It's also under a heavy load right now because the evaporator is fully loaded, so we're going to let it run for a few minutes. So after about, I'd say, 5 minutes of running, it did not quiet down. The current went up to about 12 amps, and then the guy shut off on internal overload again. Notice that we have no current. The compressor stopped pumping. I don't know if you guys can see this. The compressor stopped pumping, so the suction pressure is equalizing out. So we have a bad compressor on this guy. More than likely caused by constant on-off of high head pressure, bad condenser fan motor, and a plugged up condenser. Lack of preventative maintenance on the customer's behalf caused this compressor to go bad. So we're gonna go ahead and turn this guy off, and I'm gonna have to start making some phone calls to see if I can get approval to change this compressor. To make the process go faster and smoother, I'm getting ready to recover all the refrigerant, and I put a solenoid magnet on the solenoid valve, so that way we do not have to apply power, and the solenoid is open so we can get refrigerant from both sides. Then at the same time, I took a screwdriver and inserted it into the solenoid coil, because these coils can burn up if voltage is accidentally applied. It doesn't take very long, so if you keep a screwdriver, something metallic in there, it'll help it from burning up. And so yeah, we've got that running on that, so now we can go up and get the recovery process started on the roof. There's no compressors local to where I'm at. I'm way out in the low desert, Coachella Valley. They don't have this particular compressor, so I have a technician coming from about an hour and a half, 2 hours away. He's bringing me a compressor. So in the meantime, I'm gonna get started on this. Pretty much brought my whole van up here. Nitrogen, torches, over here. These big bags are really nice because you're able to fit a ton of stuff in there. I got scales, leak detectors, fittings, coil cleaning gun, all that good stuff. So I'm gonna get the recovery process started. We're gonna pull out the condenser fan motors, clean the condenser, get ready to change the fan motors, and we're just gonna work along trying to do everything we can before my technician gets out here. Now, I'm in an extremely dry environment, so I am gonna go ahead and remove the compressor, and it will be removed. But I'll make sure I clean everything before then, and that way there's no potential of water getting in there. But yeah, if I was in a very moist environment, if it was raining or something like that, we wouldn't want to pull the compressor out until the absolute last minute, but because where I'm at, it'll be fine. Yeah, and while we're doing this too, we'll look and see if there's anything else we can do to make this system operate a little more efficient. Maybe even putting a time delay relay on the compressor contactor so that way it doesn't short cycle as fast. We're going to go ahead and replace both condenser fan motors. I went ahead and talked to the customer. That was my recommendation, and they agreed. We have to change these motors at least once a year, so we're just going to knock them both out. They're good with that. So yeah, that's where we're at. We're going to get started. We are hooked up for an evacuation. We have core removal tools on. I am pulling through my gauges. Yes, you could do it without the gauges, but it's just easier for me. Used a large diameter hose to the machine, large diameter hose to the tank. We've got refrigerant pressure all the way to right here. We need to open this up and purge it right here. I've got some ice in this guy right here. We're sitting on the scale. So when I open this, we should be able to purge right here. Okay, that's refrigerant. And then at this point, zero out the scale, zeroed, and we're ready to go ahead and open this guy. Okay, we're gonna let it take the refrigerant, and then that is a vacuum down cylinder, I verified, and really we could just hit start. Okay, the machine is running, and we're gonna let that run, and while that's evacuating the system, I'm gonna go ahead and start pulling the condenser fan motors and getting ready to clean the condenser. All right, we got the condenser fan motors pulled out. They're just set over there for later. We're still in the recovery process. We're gonna get the condenser wet, and then we're gonna apply cleaner, but we just get the bulk of the big stuff off real quick, and then we'll get some condenser coil cleaner, and we'll get the roof area cleaned up. We'll get this all washed out from the inside out. Now, when it comes to the cleaner, this is a micro-channel condenser, okay? Micro-channel condensers, you have to be very careful and use a proper cleaner. Couple different brands. I personally use the Viper condenser coil cleaner, the yellow Venom pack. It is micro channel safe. Do your research. Don't just trust some dude on YouTube. And apply it to the condenser. Okay, so just get it on there, let it sit, let it foam. And the trick to this cleaner is just to let it sit. Okay, so I'm gonna go ahead and wet everything else down in here. Try not to soak my manifold, and then just letting the cleaner sit down in here, and then we'll rinse everything off here in just a minute. All right, the cleaner's been sitting for, I don't know, 5 minutes. I think that's good enough, so we're gonna go ahead and give it a rinse. Because we can, I'm gonna do it from the inside out. You can see clearly there's tons of dark stuff coming out. We're just gonna go to town, rinsing the whole thing, nice and slow, making sure it's thoroughly clean. You can see the dark color coming out as we're close to the water right there, to the condenser. Just keep on rinsing. So remember, when you're cleaning a condenser, clean is clean, right? Not kind of halfway clean. You need to clean it properly. All right, we're done cleaning the condenser, just kind of washing the other stuff down the drain, letting it dry up. The recovery machine, it shut itself off because it has an auto shut off low pressure cutout. So it went ahead and did that. My system is completely void of refrigerant. It's sitting in a vacuum at -3 PSI, and we only recovered 6 pounds of gas, shown on the wireless scale handle. So this guy actually takes more than 6 pounds. I know the factory max charge on this guy is 14 pounds of gas. So I don't know if it has leaks or if someone just didn't fully charge it because we're out in the desert and they were just worried about high head pressure. It's hard to say. But we're gonna go ahead and proceed with the repair and then go from there. All right, because I'm a little unsure on whether or not there's a refrigerant leak, we're actually gonna do a pressure test on this unit. I have the nitrogen, why not? So I attached the suction line temperature clamp, which is gonna help me do a temperature compensated pressure test. So as the temperature changes, it's gonna reflect that in the pressure change, okay? So we've got it set for 404. It's about 100 degrees outside, you can see, 100 degrees, and then suction line temp's about 101. So we're gonna go ahead and hit tightness test. Okay, and it's basically saying press enter to start, but we need to get pressure in there first. So I'm gonna go ahead and change my guy on over. Okay, we're adding nitrogen to the system right now, and we're gonna get it up to the test pressures of the system, which is, we'll just get it up to about 150 PSI and see what that does for us. After you pressurize it up to wherever you want it to, you need to let it sit, okay? Let it sit for about 5 minutes because the pressures kind of move around. There's still a little bit of refrigerant in the oil, the compressor, kind of things move around. So this guy's been sitting. We settled for about 157 PSI, so I'm gonna hit enter, and it's gonna start a timer. And then it's gonna give us the pressure differential on the left-hand side over there, okay? So we're gonna give it some time. Notice that it's actually rising in pressure right now, which can happen because there's still a little bit of refrigerant, and the nitrogen will actually react to temperature. A lot of people think nitrogen will not change, but it does. It's a gas. You can change it from a liquid to a vapor just like any other gas. All right, I don't know why this didn't have enough refrigerant in it, or the right amount. It may have been enough for the system to run, but it's been running for 20 minutes, and originally it went all the way up to 0.9 psi that it lost, but now it's going back down to 0.6, 0.5. So I'm comfortable with this. I'm gonna go ahead and let the nitrogen out. We're gonna go ahead and get this compressor on sweat and proceed with putting a new dryer on it and all that stuff. Again, my guy's still not here with the new compressor, but I'm confident we're gonna be fine. So we're gonna take this off, relieve the nitrogen, and proceed. All right, we got the nitrogen flowing into the suction side. We need to get a new one of these caps too. That could be a leak right there. That happens. Let's see if we can come up on a cap. I don't know that I have one of those right now, but we'll see. I've got nitrogen flowing. We've got to get this brazed in, this brazed in, and this brazed in. We're gonna push it down. I'm still waiting on a part because we needed one of the dryers that I had wasn't gonna work, so I had to send my guy to go get one of those real quick. Luckily that's available out here at one of these supply houses. So I'm gonna get this sweat in real quick and then start putting the motors in while I'm waiting for him to come back with the dryer. Before I start brazing, I put a heat blocking compound around the compressor just so we don't burn the paint. You know, it's not gonna be perfect. I'm just gonna do my best. This one I happen to be using the Viper wet rag. There's lots of different heat blocking compounds. That's the one that I like though. So I'm gonna get this sweat in real quick, and then hopefully, like I said, the dryer will be here and get those fan motors done too. We put an oversized liquid line filter dryer, so we went with the Sporlan 16 cubic inch, half-inch dryer. I did a flare as usual. Because of the space, I had to do a pre-made flare on the bottom. I know a lot of people hate those, but I have good luck with them. We've got the evacuation running right now. Everything's sealed up. We're gonna wire in the condenser fan motors. I got 2 new condenser fan motors. We've got the micron gauge right here. And yeah, we've got the gas ballast open until we get down, usually below 1,000 microns, and then we'll close the gas ballast and potentially change the oil. It just depends. But yeah, this guy's running, and remember, we have the solenoid magnet downstairs, so we're pulling completely through the system. So my evacuation is well below 1,000 microns, so we're gonna go ahead and close the gas ballast, so that way it'll start pulling through the vacuum pump oil and we can get a deeper vacuum. So right now, we're about 800 microns. It's a little difficult. There you go, about 800 microns. So we're gonna let that keep running. We're just kind of cleaning up condenser fan motor wires, making sure the ground wires are put on, making sure they're not gonna hit anything, just making it look pretty. We're looking really good, making good progress, about 570 microns. It's been running for about 15 minutes. So we're gonna let it keep running, and then we'll start, once we shut it down, we'll start adding refrigerant to it. So I'm gonna go ahead and add the full charge that I know this system takes, which is 14 pounds. That's the max charge on this system. So we're gonna put 14 pounds of 404A. We'll go ahead and utilize what was left in the other one. I don't know where the other refrigerant went, but we'll use what's left in that, and then we'll add the difference. So yeah, and then we're just about done changing that contactor. So you can see, like, I tied up the wires for the condenser fan motors, so they're removable, but they're also not laying on the ground anymore. So that way they're, you know, somewhat secure. Zip tied up the compressor wires too. They're somewhat secure. So the other thing that we did was we went ahead and installed a time delay relay over there. So that way, whenever the pressure control cuts out, that time delay relay will come in. I think it's a 90-second relay. So it just basically will cut down on the short cycling if we ever get a plugged up condenser, basically. So it's not perfect. I think it's 180 seconds, to be honest with you. Let's see if it says it on there. Yeah, 180 seconds. So that way it gives it a little bit more of a buffer time between restarts, just to try to save the compressor. Look at how dusty it is up here too. Like, this whole thing's getting covered in dust. It's all windy and nasty. It's hot too. It's still probably like 102, 103 up here is last I saw. We're currently in our decay right now. It's barely risen to 600 microns, so I'm not worried about that. I'm hooking up the service gauges, but we got to pull them into an evacuation. So I hook up the process hose, right, or the charging hose, and we're going to go ahead and pull the gauges into a vacuum before we open them to the system. So that way we can be sure that the gauges themselves aren't going to add any air into the system. Now, once they pull into an evacuation, then we will Sorry, I lost my train of thought right now. Then we will go ahead and charge the system up. All right, now's the moment. For some reason, I can't get my dang Schrader in there, so I'll have to pump the system down and play with that when I'm done. But regardless, I got high side, low side. I put in about 2 pounds. I'm gonna turn this guy on and see what happens. So let's go ahead and, would you mind flipping that on for me? And we're running. And I'm just charging through the low side. So it pumped down, and then the time delay is going to kick in because it's too low on refrigerant right now. So it's okay though, we're just going to keep charging it up. We'll hold the contactor in if anything. All the refrigerant that I pulled out is actually enough to get it running and to clear the sight glass. So we got a nice clear sight glass, but that's only about 6 pounds. It's actually just a little under 6 pounds because it's hard to get the remaining vapor out of that tank. But we're still going to put more gas into this guy because we got to fill up that receiver 3/4 of the way, so that way we have enough refrigerant for the winter time when it goes into when the head pressure control valve bypasses. We want to make sure that we have enough for the flooded charge. So I want to verify hot discharge, hot liquid, hot right here. So this and this are the same temperature, so the valve is not bypassing, so we needed to make sure on that. So yeah, we're gonna go ahead and get that other cylinder right there and go ahead and top off the rest of the refrigerant. All right, I stopped at 11 pounds of gas because that's just under the 3/4 mark on the receiver. I pumped it down and checked the liquid level, and I don't want to put any more gas in there than that. We know that it was operating with the 6 pounds, so I went ahead and stopped with the 11 pounds, marked it. We're gonna be fine with that. I'll follow up on it, but this also has a very, very short line set run. And I just don't know if I trust putting any more gas in this guy. I don't want to max this guy out. These things have a hard enough time as it is. We're looking good. Our superheat is extremely high right now. Now this is evaporator superheat. It's currently 31 degrees, but that box is really high in temp, so we need to give it a lot of time for it to come down in temperature. In all honesty, I don't even know if we'd be able to check superheat today. We probably need to follow up. But both condenser fan motors are working. Everything's looking good. Oversized sight glass and dryer, all is well. We're gonna go ahead and take our tools off and go have a look down at the evaporator coil. All right, it's much colder in here, but it's gonna take forever because it's been down since last night. So this is the discharge air, is 15 degrees. So it's gonna be a while. Realistically, I mean, everything's soft. Ice cream's liquid. So I'll probably stop back by tomorrow and do a follow-up. Looks like temperature controller says it's 18 degrees. So like I said, we'll stop back by tomorrow, do a follow-up, maybe check the evaporator superheat, make sure everything's good with that. All right, I just cut the top off of this guy. There's quite a bit of oil in there, so that's a good thing. We're gonna pull the top off. Now I did have to cut this plug off because I didn't have the tool to take it apart. So we pull that off. This is, I believe, kind of like an accumulator. They have safeties built into these guys. I already pulled the bolts, so this guy should pull off. Yep. And then when we rotate it, it's hitting. It's hitting something. Very interesting too, because I sealed this right away. So there's still refrigerant coming out of the oil. I don't know if you guys can hear it when I turn it. It's still hissing. It's interesting. So we're going to keep pulling this guy apart and see if we can get down into it and figure out exactly what's wrong with it. As far as the oil goes, I pulled out 36 ounces. I mean, it's a little discolored. We're going to have to let it sit for a while to see what's in the oil. Looks a little bit low. All right, as far as in the sump, it doesn't look bad. There's not very many metal shavings, okay? But when we look down in here, this oil is severely discolored, really bad. It's very, very dark, almost borderline like burnt, which we know the system was overheating, right? When it comes to the pistons, I don't feel any wrist pin play. I mean, everything seems to be fine with that. They're still moving, but look at the discoloration. I mean, severe discoloration on that. And then look right here. So the reeds are still intact, but look at the discoloration. severe overheat inside of this guy. Severe overheat. Alright, I went ahead and pulled the thermal overload. Let's see if I can zoom in, but this guy clearly been tripping on thermal. See, the contacts on the thermal overload are pitted. So this guy was doing its job. It's just the customer wasn't doing their job of maintaining their equipment. And you see the shape of that refrigeration oil. It's black and there's like sludge in it. It's super thick. So that's not good. And look at the discoloration in here. How dark it is. Like, it kind of wipes off, but it's horrid. That's bad. That is no bueno. Not good. It's gonna be hard to get it on camera, but I believe there's a bearing right here, right under here, and it doesn't sound, it sounds metal on metal. And I realize refrigeration oil should be in there, you know, when it's running and everything, and it should be lubricating everything, but it just doesn't sound right in there too. And I'm curious too if we were bypassing on pressure relief right there. Even though it wasn't that high, it's almost like it had been tripping. I think I'm trying to remember what that's called. It might be a TOD. I can't remember, but I believe that was bypassing, and that would make sense too, because dirty condenser, bad condenser fan motor going on and off on high head pressure. It was 100 degrees outside. It's probably been like that for a day or two, and it just kept tripping the thermal overload is what I'm thinking happened, because once I tried to reset it, you know, it ran for a few minutes making a ridiculously loud noise and then just tripped on thermal again. And like I said, you can see the thermal overload contacts have been tripping too. So, well, I came back to follow up and this thing is iced up. What the heck, man? The whole coil's iced up. So we're gonna jump on the roof, check the defrost, and see what's going on with that. All right, so we come up here to the defrost clock. Between 1 and N, we should have 208 volts, and we do. So that means the clock is powered, and the green light is on the clock. You may not be able to see it, but the green light's on. And then right now it's in refrigeration mode, so you should have power between 4 and N. There we go. But the thing is that when you click it into defrost, it pops right out of defrost. It just clicks out. Like the limit switch is keeping it from coming out of defrost. So if we go between 2 and X, or 1 and X, we have power coming from the limit switch back up, not allowing the unit to go into defrost. So I just turned it off, and what I'm gonna do is remove the X wire, which is the purple one. That's the defrost termination limit switch wire. So if I remove that, then we'll put it into defrost and confirm that the defrost works. All right, we're powered back up. We're in refrigeration mode. Let's go ahead and click it over into defrost and see what happens here. So again, between N and 4, right now we have 205 volts. That's refrigeration mode, okay? So we click this over, boom. Now it's in defrost. N and 4 loses power, okay? And then we should have power between 3 and N now. There we go, 3 and N, 204 volts. So we're in defrost. So I'm gonna go downstairs and make sure all the defrost heaters are working and get a look at that limit switch, figure out why it's terminating when it's totally iced up. So you have all your heaters coming to H1 and H2. That's each side of the 208 volt circuit. And I tested everything on H2. We have current on every one of the heaters, okay, so that's a plus. The limit switch back there is not covered in ice or anything, so I don't understand why it's terminating. It shouldn't be terminating defrost. So I believe we have a bad limit switch. Unfortunately, none of those are available right now, and they're all on back order. So we're gonna have to leave this one bypassed, but we gotta get it defrosted first. So the interesting thing is that everything in here is frozen. So it's like the box came down to temperature Even the ice cream is hard, and that's the same ice cream from yesterday that refroze. So the box came down to temperature, but then it iced up. So I think it just iced up this morning. Currently going through my junk drawer to see if I can find a limit switch, and I don't think I have one. That sucks. But on the plus side, look what I found. Yes, score. Always save these things when I throw things away. So remember yesterday when I was there, it was broken on the top. Like it had a leak or something. So we'll put that on that valve, that suction service valve. I currently have one of my other guys in there defrosting that walk-in freezer coil right now. So we're gonna get that up and running, and then hopefully we can get it down to temp to where we can check superheat, because that's what I came back today to do, was to check evaporator superheat. So I noticed that when I got back there was a bunch of icicles hanging down, right? They're in there, they're over there. It's because the drain's plugged up. These guys and the lack of PM service. So I don't know what was the start of the freezer going down. I don't know if it's been icing up and then the compressor finally died. Who knows? You know, there's just condenser fan motor, dirty condenser, bad defrost termination switch, plugged up drain. Who knows what else is wrong? Out of curiosity, I want to see if the fan delay is bad too. We have the defrost termination bypass, so I have someone turning it on at the moment. All right, now it's running. You can hear the refrigerant moving through it. So the fan delay is still working, so that's a good sign. So we just have the defrost termination portion bypassed for now. Must just be some kind of a short inside the switch or something that wasn't allowing it to defrost. So that defrost termination switch is supposed to work in the way that when it senses that the coil's too hot, it terminates the defrost by sending power on that purple wire up to the X terminal in the clock. And it was doing so when there wasn't even any ice or anything around it. I've seen it sometimes when it gets covered in ice where it'll do some weird stuff, but that wasn't the case. So there was no reason for that thing to terminate defrost. So now we're just waiting for the fan delay to kick in. And then once that happens, we'll check the evaporator superheat. Well, we gotta watch it come down to temp too, so. Those two turned on, but this one didn't. Why? Junk. Open this up and see what's going on. I didn't see the wires. I had someone else doing it, but what had happened was there's a couple spots where there was tape on the wires because maybe it rubbed out, and I lifted the tape on one of those. If I can get it to focus here. And it, there it is. It shorted. Or actually, it broke the line. The whole line is broken. So, anyways, I cut it shorter so it's not so long. Did some heat shrink splices. I'm going to tape them up and then we'll plug it back in and hopefully this motor will work. Right, so my superheat when I got here was still at like 20 degrees. Now granted the box is still coming down in temp, so we want to be careful adjusting superheat when it's still kind of high in temp. But I made a few adjustments to the valve, some preliminary adjustments. I'm probably not going to make any more. I backed the stem out 8/4 turns and we're just kind of watching the system stabilize. Right now we're at 13 degrees superheat, and again I'm not going to really adjust any more than that as of yet because I want to make sure that you don't want it to still be coming down in temp and then be way too low when it finally, you know, satisfies or gets close to being satisfied. So typically want to adjust superheat 5 to 10 degrees within box set point. So we're still a little bit high because our box set point's -10, but we're just going to let this keep running for a bit. One thing I should point out too is that you should never adjust an expansion valve before you check the strainer. This one has an external strainer. It's hard for me to catch that on camera, but I did pull the strainer just to make sure that it wasn't plugged up, and we're good on that. I actually did that yesterday real quick because I was just curious before I, you know, buttoned everything up and all that good stuff. But so far we're looking good. We're not showing any major signs of anything bad. Well, we got the box down to about 8 degrees superheat. It's about 13 degrees in here. So we're gonna leave it at that. We're gonna tell them to keep an eye on it. And next time we're here, we'll do a follow-up on it, but I'm good with this one, I'm happy. I kind of question whether or not this had ever been adjusted properly. That happens a lot on some of these new restaurants that I start servicing. Because there's nothing in the strainer and I basically had to go quite a bit on that valve, but it's all good. Everything's working. Give them the keys back and tell them to keep an eye on it. So with a repair as big as we made on this system, the contactor's majority of the time going to be part of that repair. Anytime I replace a three-phase compressor, especially three-phase, okay? Because if you have a single-phase compressor and you lose a contactor, it's not going to be that big of a deal, right? Let's just say you lose one phase of power. It's very unlikely that that's going to damage a compressor. I mean, I guess there's always some weird possibility. But on a three-phase, however, if you lose a contact point, meaning that you get, you know, a voltage drop across that contactor, you could single phase that compressor, meaning delete a leg of power going to it. And if you single phase it, you can cause an overheat situation that could actually ruin the compressor. So anytime you're changing a three-phase compressor, you always want to thoroughly investigate the contactor. Now, in this situation, I more than likely think that that thing was short cycling on high head pressure. And that would have been in, out, in, out, in, out, in, out. And that would be reflected in these contact points. All right. Now, there's always a possibility we could have gotten more life out of this contactor. But the question is, if it would have failed after and I had a brand new compressor and it's single phased and ruined the brand new compressor, how do you think the customer would feel about that? And then on top of that, that might likely fall into my warranty period. And then I might have to eat the labor, right? Because I warranty my workmanship for 90 days and then the parts, whatever the manufacturer warranties, I honor their warranty, right? So I'm warranting my labor on this job for 90 days. And if I didn't change this contactor and then the compressor failed, I would be warranting 8 hours of my labor basically to change another compressor or whatever it was going to take me, okay? So always investigate your contactors, and I highly encourage you guys to start tearing them apart so you can understand what makes them tick and what's going on with them. But yeah, those points are clearly corroded. Never jump to conclusions on these calls, and always, you know, go through the basics, right? So I knew something was a little off because condenser fan motor is running without a compressor on this particular condensing unit that I know very well is not correct, okay? So I did my best to try to cool that compressor off. And it's very important, too, that when you guys cool them, like I mentioned in the video, if you're going to cool off a thermal overload, you need to run the water over it for a while, okay? If you understand how deep inside that motor that thermal overload is, it's very, very deep, okay? So this is inside that compressor, right? And then on that thermal overload is encapsulated in the windings right there, right? So this is off of a scroll compressor, but it's the same concept, okay? So that thermal overload is overheating and it's opening, and that's, you know, completely inside that compressor. So just cooling the outside shell of that is not necessarily going to cool this, right? So you need to keep letting it run and letting it run. I mean, ideally you let it sit for 24 hours, but in the situation of this video, that wouldn't have helped, okay? So what I think was happening was I think there was a lower bearing that was failing. I think that was part of the sound that we were hearing, but then I also think that there was an internal pressure relief inside the compressor that was slightly bypassing too, causing the compressor to go off on thermal overload, high current, you know, all that good stuff. Clearly that oil in the compressor had been broken down. It was really thick. It was hard to explain how thick that oil was because it was just completely destroyed. That oil has a shelf life, you know. Copeland says that they don't want, I think, what is it, 220 degrees, 6 to 10 inches on the outlet of the compressor on the discharge line or something. But you have to understand something, that it's 220 degrees surface temperature on the discharge line. Inside that compressor is even hotter, right? And it starts to break down that POE oil. And once it's broken down, it's done, okay? It's not lubricating anymore. Then bearings are overheating. You know, it's not lubricating the places that it's supposed to. You get metal on metal action, and it's just no good. Proper preventative maintenance would have prevented this service call. And more than likely, and I'm going out on a limb here, we could have gotten another 10 years life out of that compressor, if not longer, had the customer done routine maintenance. Now, here's a problem. When you deal with big, giant conglomerate restaurant chains, you know, that across the country, all that good stuff, they take a cookie cutter approach for the most part, right? I deal with a lot of them, and they take a cookie cutter approach. So from New York City all the way to California, down to Mexico, up to Canada, Hawaii, all those different places, other places in the world, they do the same approach when it comes to preventative maintenance. So it doesn't matter in their eyes if you're in the desert, it doesn't matter if you're in the cold or whatever, they apply the same time frame, even if they do a preventative maintenance, you know, once every 6 months, once every 90 days, or no maintenances at all. Okay. In this particular case, this customer doesn't do any preventative maintenance. It's all reactive maintenance. So when it breaks, we got to clean it, you know, and that also adds another thing to it too. You go out for a service call. Now this one, you know, whatever, but you go out for a service call, and before you can even diagnose, you got to clean the equipment, you know. It's a pain in the butt, but it is what it is, right? I take what I can get. So we went through, we diagnosed a bad compressor. I had another technician with me. I had someone else picking up parts, so I was able to focus and stay busy. Instead of just sitting up on the roof, I was doing stuff, right? I recovered the refrigerant. I cleaned the condenser. I pulled the motors out. I was moving the entire time. I did a pressure test on the system to see if I could find a refrigerant leak. You know, we're taking our time, and I'm thinking, and I have a methodical way of doing things. So I try to be as efficient as possible. When I was downstairs, I'm thinking, okay, you know what? I don't want to have to come up and down a bunch of times, so I'm going to put a solenoid magnet on the solenoid valve downstairs, because I knew that way I could flow nitrogen through the system when I was brazing and doing everything that I needed to do, okay? Take into consideration, too, the environment you're working in. Now, polyester oil is... It absorbs moisture very quickly, right? It's hygroscopic. So you don't want to keep that compressor open to atmosphere for very long, right? And you don't want the system open to atmosphere. Now, the new compressor, I didn't open it until it was time to install it. But the system, I did have it open for about an hour. It's not ideal, but I will tell you that the relative humidity outside was like 6%, okay? So it's very, very low moisture content in the air. There's still moisture in the air, but it's very low. So I wasn't really too concerned. Plus, I waited till the last minute to pull the rubber plugs out of the compressor. So the new polyester oil really wasn't absorbing much moisture, okay? But, you know, you always want to be cautious about that stuff, being careful if it's raining. Going on to, you know, installing the compressor, I took my time. I made sure that I tied up all the wires. I changed both condenser fan motors because one of them had failed. The other one was going to fail soon. This particular customer agrees with me, because I'm literally, as we're typing or filming this, I just got a service call at that same location for one of their ACs, and I guarantee you it's going to have a bad condenser fan motor. To the point, because it's 2 hours out in the middle of nowhere, I'm going to take a condenser fan motor and fan blade with me. And so be it if I have to return it. But I'm going to take it with me just because the failure rate of condenser fan motors out there is insane. Because, you know, right now, it's not even summertime yet, right? It is May 5th of 2022. So it's just barely the beginning of May, and it's well over 102 degrees out there on a regular, right? And it's going to get as high as 120 during the summer. So imagine what the temperatures, the internal temperatures of those motors, imagine what the bearings, the temperatures of the grease in the bearings in those motors is when it's 120 degrees outside. It's insane, to the point that you barely get a year's life out of those motors. And it's just, it is what it is, okay? The last thing is the compressor contactor. Now, I really didn't show footage, but we did change the compressor contactor. I showed footage of the autopsy after. And then I tried to go the extra step and I installed a time delay, okay? Because I was worried about that compressor cycling on head pressure, on and off, on and off, on and off, because the customer doesn't do preventative maintenance. Now, yes, it's the customer's problem. Yes, they're the ones that have to pay for it. So why should I care? Well, I care because they call me out at 9 o'clock at night, and I don't want to go out there at 9 o'clock at night, but I have to because it's an emergency, right? So it's just one of those games where when I have the chance, I'm going to do what I can to make it last longer. Okay. It's amazing, all the feedback I've been getting from all of you. It's very, very cool. Please keep it coming. Feel free to send me an email, hvacrvideos@gmail.com. Leave me a comment on the video, interact on the video, you know, find me on social media. I'm on social media at HVACR videos on pretty much all the platforms at HVACR videos. So I appreciate all your support. Remember, be kind to one another. You know, I keep saying this and I can't stress this enough. There's a lot of craziness going on in the world, you know, and you never know what someone's going through. Not justifying them being a jerk or anything like that, but just chill out and relax, okay? I too get caught up in it, and that's why I say this stuff, because I have to remind myself all the time. I was just driving in the car with my kids the other day, and some guy was trying to merge in the middle of traffic, and I was yelling at him. right, with the windows up, but I was yelling at him, and I'm just sitting here thinking, my kids are listening to me get all pissed off, you know, and it's like, I gotta slow down, chill out, and remember life's too short to be stressed out about stupid stuff, okay? I really appreciate you all. Be kind to one another, and we will catch you on the next one, okay?